Next presentation is ICAD, the operational complement to FAIR by Wolfgang from ZONTAL.
Thank you. So I thought about the operating model, how to bring FAIR data into practice. What FAIR data defines how data needs to look like, but it doesn't really tell you how to implement it. So it's been 10 years that FAIR was defined, and the adoption is still, or the effect is still marginal. So I think Vinny said that earlier, FAIR was probably one of the most, or was it Chris, one of the most successful applications so far. So wide adoption, wide station. And we agree all of that. So I think it has inspired us all. And certainly had influenced other trope, even though other trope started a little bit before that. But I think it was like a conversion of mindset at that time. So it's a great foundation to create an alignment on how we want to manage data from the quality perspective. What is missing is the operational model for that. So the ICAD principles that I've articulated are not a product. They are, again, a set of guiding principles similar to FAIR. So created by ZONTAL, but independent of ZONTAL. So I think any architecture, any vendor or set of vendor products that can implement that architecture can benefit of the deeper understanding. So we have 4 principles. First, we need to integrate data. Once we integrate, we can contextualize, then we can analyze, and then we can decide. When we hear that 95% of the AI projects fail, it's because people start to work with decide or analyze, but they don't do the groundwork to create high quality data. So this is one of the reasons, or one of multiple reasons that's why those projects struggle. So we need to put the effort into getting the integration and the contextualization done before we can start doing the fun stuff. Not to say that integration can't be fun. So just as a core distinction, FAIR describes how good data needs to look like. ICAD addresses the question, what can we do with the data once we have it? So FAIR is a set of nouns, and you can pick any of them in a loose order. Right? So there's no requirement to have all of them or to do them in a specific sequence. What is a big difference to ICAD is we believe you need to do them in a sequence. Start with getting your integration in order in terms of context before you start to make decisions. And that's independent of AI. Also humans should make decisions based on facts if possible. So getting your data in order makes always sense to do that first. When we do that, then we have a compounding value. But the more data sources we integrate, the more context we have, the more we can learn from it. To quickly go through the principles, and so the actual documentation is like 40-45 pages, so you can download them from our website. But on a high level, so each of these main principles has 4 sub-principles. So when we talk about integration, we want to create proof at the point of creation. So typically we want to capture the raw data to have the evidence. So we discussed preservation earlier today, right, that we will need to do format updates over time. So it's helpful if you can go back to the original data to have that preserved. From the GXP perspective, we have always a question, what is the system of record? What is a true copy? Right, so that all should be validated, this whole conversion process, so that you have true copy. So when the time comes that you can no longer read the native data, that you can promote your true copy to the then primary record over time. Right? So that requires some level of discipline and process and documentation about that. We have seen also in our presentation tomorrow, this morning, how much effort it is and how long it takes if you want to do this at scale across a whole enterprise. So becoming more efficient and industrialize the process seems to be required actually to build a full enterprise context to, for example, an out-of-spec investigation. We look into context. So we want to build a context graph. I prefer the term context graph over knowledge graph. Knowledge graph sort of implies it's an RDF model for many people, and I want to have this a little bit more technology neutral. So for AI, we want to understand the context. We want to have the context be navigatable by a model. So a context graph does it. We see at Allotrope also that the ASM is not an RDF model. But the terms are defined in RDF. But the ASM itself, we could call it a semantic JSON or linked data plus kind of thing. So it's easy to process and it has all the links to semantic what we need, but it doesn't force us into using an RDF engine to process it, which has its own challenge. RDF graphs and property graphs are the two graph models that we see in graph databases, but linked data does not need necessarily to have a graph database. So we want to be technology neutral, right? So different technologies have the benefits for different use cases. Master data reconciliation, interesting thing. Right? So we are starting to define the connected domains model. So to be able to link to other domains, but there are certainly domains who are not modeled yet. So maybe that's something that Allotrope and Historia can work together on and like closing those gaps in the domain landscape. Lineage was discussed multiple times in different contexts today. Right? So we not only want to have data described, but we want to have it linked that we can trace through the provenance of how the data came into existence. And finally, we want to have it machine readable, human readable, of course, as well, but machine readable. Once we have contextualized data, we can analyze the data. So, for example, applying statistical methods. On top of that, to compare data, trace, and use insights. Right, so that's sort of the layer that we need to go through before we can start to decide. And this decision can be a human who looks in a dashboard or an AI model that acts on the data. Anyway, so without analysis, just work on the raw data without analyzing it. It's hard to make decisions. We discussed data products earlier today. So in theory, we could say this analysis and decision is part of data product. Right? So you could use any data lake product, Snowflake, Databricks, whatever, to implement that. Or you can do it in a more ad hoc, agile fashion for the questions that you didn't know before you had. So there can be multiple ways to implement those principles depending on the use case. Those dashboards in data lakes are great because they're just fast, not to build, but to query. Right? If everything is pre-aggregated, they're very responsive for. And finally, if we go into the decision layer, if we think about the GXP environment and we apply AI to make decisions, we want to have this complete evidence documented, explainable AI, and understand where does it come from. In one of the last presentations, we saw how to create this for models, right, to have all evidence chain and how the models evolved. We want to have the same for the data, so that both together can be traced back to the source. So this means from the integration to the contextualization, to the analysis, to the decision. So again, I have a video. Unlike the previous one, this is a vision video. So it's not a product that actually exists, but it's meant to serve as inspiration. So once you have all this done, what are just a few use cases that you could implement? Let's see how that goes. Can you share the sound again?
Welcome to this ZONTAL web series on putting ICAD principles into practice. In this video, we'll explore how ICAD principles help close the operational gap between fair data and the realization of its full value. Integration and contextualization have already been established through converter factories and data lineage. In this session, we focus on analyze and decide, enabled through an intelligent, data-driven environment. With ZONTAL, organizations can analyze fully contextualized datasets enriched with standardized metadata. It provides a unified way to work across data from multiple techniques and technologies, bringing everything together into a single, trusted foundation. Within this environment, statistical models can be developed and insights generated across entire projects, all anchored in a consistent source of truth. From here, decisions can be made with confidence, grounded in governed data and augmented by AI. Because the data has passed through integration, contextualization, and analysis, it remains fully traceable, manageable, and configurable throughout. This environment provides seamless access to the full data landscape. Users can explore data, genealogy, and lineage through AI-assisted search and intuitive visualizations. Data can be accessed through interactive views or by navigating directly to source systems, effectively removing traditional data silos. For example, when searching for an entity, related data and connections to originating systems are immediately visible, enabling faster orientation and deeper understanding. Relationships and lineage across the data ecosystem are visually represented. From here, a user can select a drug substance and explore its associated metadata, results, batch identifiers, and related measurement data. Direct links to systems of record provide access to additional relevant information. At the same time, an AI assistant can be engaged to explore relationships, request additional data access, or suggest next steps based on observed patterns and measurements. Multiple data points can be selected and brought into a unified analysis. This enables direct access to governed, contextualized data across disciplines and techniques, supporting comprehensive insight generation. Batch comparisons become significantly more efficient, with statistical models applied while maintaining full provenance. Predictive analytics can be performed using historical batch data, highlighting risk levels and identifying the variables contributing to those risks. Through AI-assisted interaction, users can query the data and generate outcomes such as shelf life predictions or root cause analyses, accelerating understanding and decision-making. Out-of-specification investigations can also be aggregated across selected data, providing a fully contextualized view of affected projects and batches, including failed specifications and tests. This approach enables faster identification of root causes and clearer understanding of failure drivers. It reduces the need for cross-departmental data gathering and eliminates reliance on fragmented systems, delivering immediate, actionable insights. An insights layer provides a consolidated overview of selected data or projects. It includes notifications, watch lists to track ongoing activities, and automated report generation for studies such as stability or ad hoc analyses. Finally, all governed, contextualized, and analyzed data can be compiled into automated I&D reports. Here, an I&D report package is generated from validated data across the project. Scope, data sources, and configurations are defined as needed, and the final document is produced to required regulatory standards, with full traceability of all underlying data. Processes that traditionally take weeks or months, involving multiple departments for data collection, review, and validation, are streamlined dramatically. With ZONTAL, these reports are generated from already governed data and can be ready within minutes.
So just as an idea where this could lead to. So now the question, since we had a little conference, what is Allotrope's contribution to implementing those ICAD principles? So Allotrope certainly provides a lot of value for the integrate step, and so we can use this schema to capture the data. We can support the dual representation So what I mean here is the proper files and then the ASM files. We can use the links allotrope to provide that linkage for the provenance. The technique specifications help to create these reusable and versioned assets, right? And then for the factory, the technique specifications were incredibly helpful because we have a specification to work against, right? If you ask AI create some JSON file, you get some JSON file. If we give it an exact specification, we can hope to get that specification. So it makes word of difference. So but without the ASM specifications, the factory is good. So for the contextualization, the context linking certainly is an integral part of any knowledge graph-based or ontology-based technology. For the master data reconciliation, I think we can provide a linkage to resolve master data. We yet need to define how to express those master data terms. So could be a future set of allotrope models. The end-to-end lineage, again, is a matter of...
Yes, but I wanted to ask you, would this one be something for you? Yeah. This is a real logic, I think.
A question to us or a background conversation?
It's hard to read, it's just a comment.
Ricardo, will you please mute yourself? Thank you.
Can we do that? Pizza, anyone?
Good.
Good. So providing the linkage as being a linked data model, that's almost trivial using ADF as an and machine-readable is all the point of allotrope's existence. So if you map allotrope here one-to-one to the principles, just to summarize that. So to capture at the point of creation, we use ASM as a schema to express the data for the vendor native and plus standardized representation. We can have ASM plus the native files stored together, creating a link. Reusable version integration assets. So the technique specification evolves over time, right? And ASM has a link to the specification, so that version is also built in for the scalable onboarding. The allotrope compliance helps to create input that's output that's compliant across like a family of instruments, so that we can overlay data captured from different sources. Right? For the contextualization principle, the scientific context links is part of the vocabulary that can then branch into other domains. Same with the master data, where we also then create a semantic structure around how to do that. Lineage, again, is based on existing terms that we have already defined in allotrope. And ASM and AFA combined help us with machine-readable context. So one of the challenges that the pharma company faced is a patent cliff, right, which may have a big impact. So there are estimates that can go into multiple hundreds of billions. So we need to find a way to be more rapid evolution and implementing new processes. So pivoting to more portfolio-based operating model at the pharma companies also requires that the add-on system integration also becomes faster. Not everything can be like 5 years a project to get that done. Right? So that really emphasizes the need that we also need to change the operating model of how we run integrations. So maturity-wise, most companies have started, but I haven't seen yet any company who completed the exercise, really focusing on integration and context makes, I think, a lot of sense, and this is where most of us are. Right, so the analysis and decision is not really connected yet, like broadly to the allotrope environment. I think doing this homework is a critical thing. And once we have that bottleneck out of the door, then the rest should go much easier. So at Allotrope, we already address the first two principles. We can formalize the mapping that I've just proposed. Certainly, ICAD principles is like an early specification, so I've reviewed that with a few customers and partners. So happy to collect more feedback. We will launch a new website soon, which also then supports doing a self-assessment to see where we are and provide feedback to improve that further. So we have published that also under the CC BY license. So free to use and modify. And yeah, happy to collaborate on that. So any questions, comments, discussions?